Hey guys, it's Miss Davis. We're going to go over this M&M problem simply because there's a couple different ways you can solve for it when you have percentages. So I wanted to go over that with you guys, and then you can just check your answers. If you're ever curious about chi-squared and you kind of want to do your own problems, these numbers right here, these are the actual numbers from the M&M website. So if you're ever curious, you are more than welcome to seek out. You can get like the big bags. Those are actually better, which we'll talk about here in just a little bit. So the problem is you buy a package of M&Ms from the factory store and you find the following. You have 20 brown, 20 blue, 20 orange, 20 green, 20 yellow. According to M&M, you should have 13% brown, 24% blue, 20% orange, 16% green, 13% red, and 14% yellow. So if you come back up and you look at your M&Ms, you're actually seeing that you have zero red. You have 0% red. So is this something that's acceptable, or is it statistically okay to be missing that 13% and to distribute it elsewhere? So that's what chi-squared is for. It's saying, is this okay that it's off by this amount, or that you have these numbers missing? So there's a couple different ways that you can solve this, and it's really up to you and how you want to do this. You can either convert your numbers to percentages. So you can take your whole numbers and convert that to percentages. The other thing you can do is you can convert your percentages to whole numbers. Okay, so it's really up to you how you want to do that, but I'm actually going to do the first way up here, where I'm going to convert these 20, the 20 of each into percentages, just so that you can see that percentages can be done. You just basically drop the percent sign. So, alright, so, and don't forget our chi-squared is going to be equal to the sum of your expected, observed minus expected, and we're going to square that all over your expected value. Alright, so observed minus expected, and then you're just going to do that over and over and over again for every color. Now that's every color in the observed, in the expected realm, so you're going to have one for red. So we have, let's go ahead and do brown, blue, orange, green, red, and yellow. Okay, so I'm just going to make a little chart here, organize my thoughts. Alright, so I have expected, and then I'll have observed, and then I'll put chi-squared down here. Okay, there we go, there's my chart. Alright, so expected for brown, I'm just going to put in the percentages. Alright, so we've got 13% for brown, 24% for blue, 20% for orange, 16 for green, 13 for red, and 14 for yellow. Now up here, the numbers are kind of easy in that all of these are out of 100. So your observed is out of 100. So it'll be 20% brown, but you could do that with anything. So if it's out of 302, then you could convert that just into percentages and then just drop the percent sign. So we have 20%, 20%, 20, 20, 0%, and 20%. So we have our expected values, we have our observed values. So now you're going to set up chi-squared for every single one of these. Okay, so we'll do these first two, just setting up the equation. Then I'm going to pause the video, fill in the rest, and then I'll keep going with the video. Alright, so we have 20 minus 13, and then we're going to square that all over 13. Okay, so observed minus expected, we'll square that number all over the expected. Do the same thing for blue here, so 20 minus 24, square that number all over 13. So I'm going to pause the video. I'm going to keep going through and fill out the rest of the chart while you guys should be doing the same. Alright, so filled out the rest of my chart. I did realize I made a mistake with this expected value. I put originally 20 down there, and I put 13 down there, and it should be 24. So, alright, so then, once you have your equations set up, you're going to go ahead and start solving them. Okay, so if we take, so let's do, again, we'll do our first couple, then I'll fill in the rest of the columns here. So if we take 20 minus 13, that's going to be 7. So we're going to square 7, which is 49. Okay, and then we divide it by our expected value, which is, we get 3.76. Excuse me, 3.77. Okay, so then we'll do the same for the next one. So 20 minus 24 is going to be negative 4, but then we square that, which will give us 16. 16 divided by 24 is going to give us 0.6 repeating, so we'll just round that to 67. Okay. So I'm going to continue going and putting the rest of our values in, so I'm going to pause the video. I want you guys to keep going and you do the last 4 columns on your own, and then we will solve and see if statistically our bag of M&Ms is okay, or if you could write a letter to M&Ms and possibly get a free bag. Alright, so we filled in the rest of our chart. So now to finalize chi-squared, you're going to take all of your chi-squared numbers here. You're going to add them all together. Okay, so let's go ahead and plug those in. So we got 3.77 plus 0.67 plus 0 plus 1 plus 13, that one's going to kill us, plus 2.57. So you get a final answer of 21.01. Okay, so this is our chi-squared value. So what we're going to do then is I'm going to pop back over to this. All right. Now don't forget our degrees of freedom. That's going to be your number of observed minus 1. Okay, so and that's right up here. So n, which is the that's going to be your number of categories, and then minus 1. So we had 6 different colors that we could use. So 6, and then we're going to subtract 1. So that'll give us our degrees of freedom of 5. Okay. Now if we're trying to go for 95% accuracy, the number that's kind of your breaking point is 11.07. So your critical value is 11.07. Because our number is higher than that, it's actually 21.01, we can actually reject our bag of M&Ms as being statistically incorrect. Something went wrong at the factory. So, and I think, I've never done it, but from what our AP Bio coordinator told us, that if you write into M&Ms with your statistics and all of your data here, they will actually send you a free bag. So, so that is chi-squared. You can use it on a lot of different stuff. You can use it on animal behavior. You can use it on animal behavior. You can use it on ecology and seeing how many of different types of species are in a set area. These are all things that actually when I get back we will practice, specifically for those of you taking my final and not the AP Bio exam. So again, you can use this video, you can use Bozeman, you can use Khan Academy, any of the other videos out there to help solve for your chi-squared. And just keep in mind, guys, that as I'm gone, there's lots of stuff out there that'll help you study and review and go over the material. So if you're not understanding something or you're having issues with it, please, please, please seek out. You're going to have to seek out and find yourself. Okay? No, it's not exactly ideal, but just kind of the way it is. So make sure that you are taking advantage of the internet and you're taking advantage of, Miss Young could even help you, as could any of the other bio teachers really in the building. And then you can always email me. I've been pretty good about getting back to emails pretty quickly, so especially for your class. But yeah, so work on chi-squared, and if you have questions, just let me know. Thanks.